All right. I'm going to take this opportunity and discuss or elaborate the various covariance matrix approach to portfolio standard deviation or portfolio variance. Okay. So first of all, I think I've caused a lot of confusion already. So I'm going to, take the time and produce this video, and I want all of you to watch it. All right. So let me provide you with a little basics of matrix and matrix multiplication. Okay. All right. So first of all, what is a matrix? So I can actually make a lot of different matrix here. For example, I can say this, 1, 2, all right, 3, 4, 5, 6. This is a matrix, right? It has 2 rows and 3 columns. Okay. So I'm going to say um, this. All right. Maybe I should actually, make this bold. All right. The bold red is a 2 by 3 matrix. Okay. And I'm going to actually produce another matrix. Okay. So this time I'm going to have, all right, 3, 4, 5. Okay. And 6, 7, 8. All right. I just make up all the numbers. Okay. All right. So this, all right, is another matrix. So let me just put this in green and in bold. All right. So the bold green is, all right, what's the dimension? 3 rows, 3 by 2 matrix. Okay. So let me just call this A. Let me just call this B. All right. So now, sometimes you want to actually multiply matrices. So to multiply A by B, all right? So A times B, okay? So what do? All right, if you want to do this brute force way, then I'm going to do it here, all right? First of all, I'm going to take all the rows, excuse me, I'm going to take all the columns from, matrix A, and I'm going to do all the rows, for matrix B, and I'm going to do this for each column, each row, and, all right, so I'm confusing myself. All right, so let me slow down here. All right, so if you do this matrix multiplication, a 2 by 3 times a 3 by 2, so yes, it can work. All right, so A has 3 columns and B has 3 rows. So yes, all right, the conformity condition is satisfied. Okay, so yes, you can multiply them. All right, so if you want to multiply them, if you do A times B, the resulting matrix is, what's the dimension for this matrix? Okay, as we said, if you have the 2 by 3 times the 3 by 2, then the 3 and the 3, they cancel. So you're left with, right, the resulting matrix has the same number of rows as A and the same number of columns as B. Okay, so that means the resulting matrix is going to be a 2 by 2 matrix. So if I want to actually replicate this, so I'm going to actually highlight these 4 cells. This is a 2 by 2 matrix. So I'm going to do a multi, right? So I'm going to take this matrix, okay, and this is my first matrix. This is my second matrix, all right, okay, and I'm going to press Control Shift Enter. Yes, that is going to be my resulting matrix, okay. So this one here, this is, let me just put this in bold green, all right. This is the resulting matrix from doing A times B. Okay. Now, if you want to do this brute force way, let's replicate this, step by step. All right. So if I want to do this, multiplication by hand instead of doing this matrix multiplication function in Excel, then what I need to do is I need to actually generate four matrix elements. The first one is going to be from the first row and the first column in these two matrices. All right, so I'm going to do 1 times the 3 here, all right, plus the 3 times the 4 here, plus the 5 times the 5 here. All right, so that, yes, that will get you 40. Okay, so immediately you realize what this conformity condition means. All right, you see that the number from the matrix, from A, you take every number, in every row, and that number has to be, that number has to be multiplied by the corresponding number in each, column in matrix B. Okay, so that means, the number of, columns in matrix A should be the same as the number of rows in matrix B. Otherwise, this multiplication is not going to match. All right, so I'm going to do the second matrix element. All right, so that's going to be the second row and the first column. Okay, so I'm going to do the 2 times the 3 plus 4 times the 4 plus 6 times the 5. So that is going to get me the second matrix element, which is actually from the second row, first column. Okay, so that is my first column for the resulting matrix. So I still need to do 2 more. So I'm going to actually now repeat this process. I'm going to do 1 times 6 plus 3 times the 7 plus 5 times the 8. So that will get me the first row, second column. And yes, that's 67. Okay. So the last matrix element in the resulting matrix, matrix is, again, I'm going to take the, second row from matrix A and multiply that by the second column in matrix B. All right. So this is going to be 2 times the 6 plus the 4 times the 7 plus 6 times the 8. All right, so that's 88. So yes, you can do this manually, but now immediately you realize that using the matrix multiplication function is actually so much more powerful. Okay, instead of doing this brute force way, yes, you can do it. But mathematician says if you want to multiply numbers in this manner, I'm going to actually propose the matrix multiplication, and this is how you do it. Okay, so I hope this can open part of the black box for matrix multiplication. All right, good question. Can we do B times A? Can we do this? Can we do B times A? Can we put B on the left and the A on the right? All right, let's see. Let's see what we can do. All right, first of all, we check the dimension. B is a 3 by 2. Okay, A is a 2 by 3. All right, so B, all right, has 3 rows, and B has 3 rows and 2 columns. Okay, A has, all right, 2 rows and 3 columns. Okay, so can we actually do, all right, so we know the conformity condition is actually for the matrix on the left, the number of columns, all right, should be the same as the matrix, should be the same as the number of rows for the matrix on the right. So if I do this, I'm going to actually have the 2 columns here and 2 rows here. Yes, they can cancel against each other. So I'm actually going to have a 3 by 3 matrix. So I'm going to do matrix multiplication here, and now I'm going to take B, I'm going to take A, all right? So close the matrix multiplication, Control Shift Enter. Yes, that's going to be your resulting matrix. This is, all right, this is B times A. This is A times B. So immediately you realize that the dimension actually matters quite a lot, and it also matters as to which matrix you put on the left and which matrix you put on the right. Okay, so that's for matrix multiplication. All right, portfolio variance covariance matrix. So this is going to be an interesting matrix here, and if you have like 3 assets, all right, so your portfolio has 3 assets here, A plus B plus C, okay, and you can actually decompose the weights in this manner. For example, 40%, 40%, and 20%. Okay, so that is going to be your weight for these three things. Then the variance covariance matrix. Okay, for your portfolio is going to be between the three assets. All right, so I'm going to have a 3 by 3 matrix. Okay, so A, B, all right, A, B, and C. Whoops, A, B, and C here. All right, and also I want to have ABC. So what I'm going to do is I'm going to actually use my transpose function here, transpose ABC from a row into a column. Okay, again, this is it's an array function, control shift enter. All right, so now we just need to populate the variance for A and variance for B and variance for C. Let me just make up some numbers. All right, so 0.2, and this is 0.5, it's 0.4, and this is 0.3, 0.3. Okay, and let me just look at this covariance. So whatever numbers, I'm just going to make up 0.25 and negative 0.15. All right, so we know this matrix is going to be symmetric. All right, so I'm going to actually do the transpose here again. So I'm going to transpose this row into a column. All right, so that is how I'm going to fill out this. And let me just make up another number here, 0.25 negative. All right, so I hope I don't run into any problems of any internal inconsistency. All right, so now let me look at the weights for your weight matrix. All right, so I'm going to have 0.4, 0.4, and 0.2. Okay, so yes, they add up to 1. All right, so if that's the case, portfolio variance matrix, portfolio variance calculation, right? So in class, I actually did the two-step, illustration. All right, step 1. All right, weight matrix on the left multiplied by the variance covariance matrix. All right, so now let's look at the dimension. Weight matrix is a 1 by 3. Okay, all right. The variance covariance matrix is going to be a 3 by 3. Okay, so if I do this multiplication, the resulting matrix, right? So the resulting matrix is going to be, what's the dimension here? I can't even pronounce results. Resulting matrix is going to be, what do you think? Look at what do we have here, all right? So the resulting matrix is going to be the same number of rows for the matrix on the left and the same number of columns for the matrix on the right. So that's going to be 1 by 3. Okay, same number of rows for the matrix on the left, that's 1 row. Same number of columns for the matrix on the right, that's 3 columns. So the resulting matrix is going to be 1 by 3. So yes, I'm going to go ahead and do the matrix multiplication here. All right, so this is the weight. This is the 3 by 3. All right, so Control Shift Enter. Yes. All right. So resulting matrix and step number 1 or step number 2. All right. So the resulting matrix in the first step, we need to actually put this on the left and multiply that by the portfolio weight matrix on the right again. All right. So the resulting matrix is 1 by 3. So we know we need to have a 3 by 1 in order to actually do the matrix multiplication. If you do a 1 by 3 times a 1 by 3, it's not going to work. Why? Because you have 3 columns for the matrix on the left and only 1 row for the matrix on the right. So you cannot multiply them, right? So need a 1 by 3. So that's why I know I need to actually transpose, all right? So if I transpose and if I do the multiplication, the resulting matrix, what's the dimension? Resulting matrix is going to be having the same number of rows for the matrix on the left, which is 1, and the same number of columns for the matrix on the right, which is 1 here as well. So the resulting matrix is going to be 1 by 1, which is actually a scalar. So I can just do it here. All right, matrix multiplication. So I'm going to take this resulting matrix from the first step, and I'm going to multiply this by the transpose of the weight matrix. All right, so close the transpose, close the matrix multiplication, Control Shift Enter. All right, so that is your portfolio variance. All right, so portfolio variance high-tech formula. All right, so I'm just going to compress these two steps into one single step. I'm going to do matrix multiplication. I'm going to do matrix multiplication. I take the weights, I take the variance corresponding matrix, and then I do the transpose. All right, so I'm going to transpose the weight matrix again. Close the transpose, close the matrix multiplication outside. Control Shift Enter. Yes. All right, so that is the portfolio variance corresponding matrix. Okay, this is the only way I teach you. All right, so if you want to practice on in the formula, by all means, but in our exam, in our homework, you're going to actually rely on this variance corresponding matrix to do the calculation. Okay, so I made up all the numbers of the variance corresponding matrix. In the exam or in the homework, you may have to construct this variance corresponding matrix first, and then you can do the multiplication. Okay, I hope this video is useful. All right, so I'll stop the video here.